Welcome back guys, this is Ashwin here. In this video we are going to see about how to delete an element at the middle of the linked list. So far we have seen how to delete at the beginning and the end. So here we are going to see how to delete at the middle of the linked list. So let's see this with an example. So here also we have two cases. So let's consider I have to find the element x. So this x I have to delete. Let's consider it as 5. So in case 1, head pointer as the element. So head has element x. So let's consider a linked list. So I have created 3 nodes. So the element x is at the head pointer. So 5 will be here, and 7 is here, and 3 is here. And the last node will be pointed to null, and this will be pointed to the next nodes, and this will be pointed to the next node, and this is our head pointer. So apart from this case, if there is no element in the linked list, means we will just return the function, and this is the second case. So if the head pointer currently has the element, means what we are going to do is we will be transferring this head to the next. So we will be removing this thing, not removing, we will just transferring the head pointer. So the head pointer will be transferred here. So we have deleted the element 5 from the linked list. So this is case 1. In case 2, element is at somewhere in the middle. So I'll just create a linked list so we can able to track it. So I have created 4 nodes here. So I will say n equals 4. So the last element is pointed to null. So I will place the element x, that is 5. It will be here, and I will mark this element as 1, 3, and this will be 2. Let's connect these things. So this is our linked list, and this will be the head pointer. So similarly, I will just create some duplicate lists so we can able to track the iterations. So I have just created 3 duplicates, so we will be tracking each iteration. So for here we are going to initialize 2 things, that will be temp. So we will be creating this new variable temp, and we also will be creating another variable called previous, that will be pointing to null initially. So this is the initialization step. So in the first iteration, so I will say iter. So in the first iteration, we will check whether the temp has the data. If it's not, means we will move the temp to the next pointer, and we will copy the current temp value to the previous. So the updation will be happening like this. So previous will be pointed to here, and temp will be pointed here. So in the second iteration, so here it will check whether the temp is equal to the data x. So our x value is 5, so it will move to the next. So prev will be pointed to here, and temp will be pointed here. Now we have finally reached the element. So we'll be doing some operations. So this is one case. On the contrary, if we don't find the element, or we have reached the end of the list, means we will print element not found. so we don't have to delete anything. But if the element has been found means we will be doing certain operations. So what I am going to do is pointing this previous pointers next to the temp of next. So that will be here. So what will be happening is, so I will be pointing this next to this one. So I'm just removing these links. And this temporary variable you can able to free it, or it will be automatically be freed. So it doesn't matter. So we are just assigning this next pointer to the next of temp. So we are just actually skipping a node or element. So that is a simple way to delete an element in the middle. So finally we will be returning the head pointer. So head, we didn't change anything, so we will be returning this head pointer. So apart from this, we'll be seeing the time complexity. Here the time complexity will be order of n. So I will say time complexity, that is order of n, because for finding this element we may able to traverse till the end of the linked list. So the worst case scenario is the element is not found. So that's why that complexity is order of n. We will be traversing all the elements in the linked list. So that's how we can able to delete the element. Let's see this with the help of algorithm. As usual, I will just name the parameters. So head is head pointer of linked list, and the second parameter x, that is element to delete. Next we will go to the algorithm delete at middle. So we will be passing the head pointer and the element to delete. So we will be handling the first case. In the very first we'll be having no element in the linked list. So for that, head equals null, we will just return it. So we'll just return the function, or we can also return the head, it doesn't matter. And in this case we have seen here head as the element x. So to check the condition, if head dot data equals x, we will be moving the next pointer of head. So we will be assigning the next pointer as head. So head equals head dot next, and finally we will returning the head. So this is the case 1 we have seen in this example. So after this we will be going to the case 2. So here we have to initialize two things, that is temp equals head and previous equals null. So let's initialize that. So initialize temp equals head and initialize previous equals null. So now we will do the operation. So we'll be traversing till the end of the linked list, or we'll be traversing until we find the element. So that is the condition we are going to provide. So for that, while temp dot next not equals null and temp dot data not equals x. So these are the two conditions I am going to provide. So if this condition satisfies, we will be assigning previous equals temp, so that we are doing here, and temp equals temp dot next. So like this we will be traversing throughout the linked list. When we have reached this condition, that is if we reach the end of the linked list, or we have found the data, we will be dealing that with a separate condition after the while loop breaks. First we will check whether the data is found or not. So if temp dot data not equals x, so we will print element not found. or else we will assign previous dot next equals temp dot next. So prev dot next equals temp dot next. So that means we have found the element and we'll be doing this operation. So finally we will return the head pointer. So return head. So this is the whole logic of this algorithm. So this is our algorithm. Let's recap it quickly. So at the first we are just checking the base condition, that is if the linked list has no elements we will just directly return the head pointer. So in this we have the case head has the element x, so we are checking for the condition. If it is yes means we will just shifting the head to the next. So after assigning it we will just return the head pointer, and in this case we have to find the element and based on that we have to delete it. So we will be initializing two pointers, like temporary that will be pointing to head and previous pointer that will be pointing to null. So in the while loop we will be traversing until the end of the linked list, or we will be traversing until we find the element. So it will do this condition. So we will be shifting this prev and temp for each iteration. When the element is found we will be checking if the element is there. So if it is not there means we will just print element is not found, or else we will do the operation, that is previous dot next equals temp dot next. So this prev node will be pointing to this node with the element 2, and finally we will be returning the head pointer because we didn't change anything in the head, so we will be returning that. And that's it guys, we have successfully done deletion at the middle of the linked list. So if you have any queries related to this video, please leave a comment below. Apart from that, if this video is helpful to you, hit the like button and share the video to your friends if it is helpful, and I will see you guys with a new video.